Hello students, welcome to the next lecture on the CSR UGC NET Mathematics. Today we will discuss about the PY questions on the partial differential equation from the year 2011 to 2023. You can simply follow my YouTube channel where you can find the various PY questions on the several topics. Otherwise you can simply scan and join my WhatsApp group. What you will find on my YouTube channel, there is a playlist of the CSR UGC NET where you can find the PY question, the real analysis from the year 11 to 23, PY question of the ordinary differential equation, Markov chain, statistics solutions, real eigenvalues problem, linear algebra, differential equations, calculus of variation, integral equation, all from the year of 11 to 2023. So we will see how you can solve all these questions in a very simple manner. We will discuss more than 50 plus questions in this video. So before seeing this video, I must recommend that you can see my previous video which is related to the December 11 to 23. I have already discussed the several shortcut tricks in this. So we will continue from here, and several questions we can solve directly with the help of the shortcut tricks as I explained here. So let's start with this video. So whenever there is a question related to the characteristics curve of the PD, so basically they are talking about the parabolic, they are talking about the hyperbolic, and they are talking about the elliptical. So whenever they are talking about the parabolic, we always get that two real and equal roots are there of the characteristics curve. Whenever there is a hyperbolic, again we will get that two real but they are of the distinct roots is there. And finally, when you are talking about the elliptical, then we will get the two complex conjugate pairs roots are there. Now if you read this statement, they are talking about only for the characteristics numbers. Whether they are talking about the real or the complex roots, it is not given. So in each case we will get as the two solutions. So the right answer is my here. If they are talking about the real number of the roots, so how you can find that? You will find the b square minus 4ac and identify whether it's a parabolic, elliptical or hyperbolic. For example, at this point, this is my a, this is my b, this is my c. At the point x1, a is my 3, b is my 1, c is my 0. So what is the b square minus 4ac? 1, which is greater than 0. So that means this is a hyperbolic. So if they are talking about the real number of the roots, then we get a 2 is the right answer. If they ask you how many complex characteristics roots are there, then it will be the 0. Again, this is there. So if you compare them, a is my here, b is my 0, c is my 1. Always remember, a is the coefficient of the uxx, b is the coefficient of the xy, c is the coefficient of uyy. So what is the b square minus 4ac? This is b square minus 4ac is 4y. So what will happen when you get as a b square minus 4ac? It will be a parabola, it will be a ellipse, or it will be a hyperbola. Parabola means is equal to 0, ellipse less than 0, hyperbola is greater than 0. So when it will be equal to 0? When y is equal to 0. When it will be less than 0? When y is less than 0. When y is greater than. Elliptical for all the values of the y, which is not possible because elliptical only when y is less than 0. So elliptical when y is less than 0, correct. Hyperbolic when less than 0, wrong. Parabola for all the values of y, not, because parabola is only when y is equal to 0. So the right answer is my C is the correct answer. Now look at this another time. So whenever there is a question related to the infinite, unique solution and more solution, how you can solve that? That's a very simple target. You have to write like this: coefficient of the x, a, coefficient of the y, b, right hand side is 1. Now whatever you want to write in the denominator, that is from the initial solution. So look at that. If I consider x is my t, what is the value of the y? 1 minus at over b. What is the value of the u? U is my x is my t. Take the derivative at here. What is the derivative of the x? 1. Derivative of the y with respect to t, minus a over b. Derivative of this is 1. If, look at that, if instead of this a, if I say this is value my x, so you have to write here, then again you have to substitute the value of the x as a t in this case. But here this is only as a is t. Now if you simplify them, it is a minus b square over a is 1. So what is the tips for you? As I discussed in the previous video, if the first two values are not equal, then we call as the unique solution. If first two values are equal but the last value are not equal, then we call as the no solution. If all are equal, then we call as the infinite solution. Now here you can see these two values are non-equal. So what is the meaning of that? It has a unique solution is the right answer. Make sure that this method is applicable only when none of them is a 0 by 0 form. If I say this right hand side is 0, here is 0, if this is also 0, then 0 by 0 form, then you are unable to compute the result based on this method. Then you have to solve the problem by using the Lagrange equation, dx over this dy. The same kind of the example we will cover in this couple of the examples. Again they are talking about the unique solution, linear, and here so coefficient of the x, y, right hand side. So if I consider x is my t, what is the y? Y is 3 over 2t. What is the u? U is my 1. So take the derivative 1, it is 3 by 2, it is 0. Now clearly say that it is 2, it is 2, it is infinity, which is not same. So that means no solution. So the right answer is here. Infinity is fine, but 0 by 0, that is the indeterminate form, is not solvable. Now look at this condition. So remember that whenever we are talking about the ordinary differential equation, I already gave you several tips like of this. Whenever this condition hold, y of 0, y of L is 0, whenever x lies between here, what is the nature of this lambda? It is positive. The value of lambda will be n pi by L whole square, and the solution will be a sine n pi over Lx, and this is countably many values. Fine. So we will use the same tips for here. You can see if I think about here as a u double dash in terms of partial differentiation, then it is similar to this. So whatever the value of the lambda, what is the L is? L is 1. So what is the value of lambda is? N pi square, which is a positive always. So you can see a unique solution cancel because it has infinitely many solutions. So infinite many solution for some lambda, that's correct. Countable many solution, that's correct statement. Infinite many solution for all the values of lambda is a wrong answer because it's infinite only for the sum arc. Now there is another tips for you. You can see whenever there is a coefficients, whenever the coefficients are constant and the initial condition either in the x comma 0 or 0 comma y, they are in the form of the exponential or in terms of the sine or cosine, then you can write the directly solution in terms of here. Whatever the solution is given to you, this is in terms of y, so you can write the another solution as phi of x. How you can find the value of the phi? You can substitute this value here. Take the partial derivative with respect to phi or with respect to x is a phi dash 4 e raised to power minus plus 2 times take the partial derivative with respect to y. So it is my minus 8 phi e raised to power minus 2y is equal to 0. So I can take 4 common, e raised to power minus 2y common, it's a cancel out, plus minus 4 phi is equal to 0. So it's a simple ordinary differential equation. So n minus 4 is 0, phi is my e raised to power 4 of x. So what is my solution? So you can see my solution will be u is e raised to power 4x and 4 times e raised to power minus 2y. Now you want to find the value at 1 comma 1. So what is the answer of the 1 comma 1? E raised to power 4, 4 e raised to power minus 2 is the right answer. So remember always this shortcut trick is applicable only when the coefficients are my constant and either of this form. Again you can see this, the coefficients are constant and the solution is given in this form. So I can take this as sine of x. Now it is in terms of the x, another is y, so I can consider this is pi x, sorry, and I can take as a t. Okay, so how you can do that? So I can take the partial derivative t, I can substitute here sine pi x phi dash, take the second derivative minus pi square sine pi x of phi. So pi x will be cancelled out, phi dash plus of this is 0. So the solution will be e raised to power minus pi square t. So what is the solution is minus pi square t sine of pi x. This is the first method. I will tell you one more shortcut tips for you. Second tips. Look at that, this is my heat equation, fine, and the constant is my C is my 1, fine. So what is the shortcut tricks for you? Whenever there is a heat equation and it is in the form of either the sine or cosine, then there is no need to do like this way. This is always with the solution of minus a square of t, or in more general I can write for you here as e raised to power minus a square t, whatever here, if c is equal to 1. Otherwise you can simply write as a, so in this case you can see c is my 1. So how you can write the solution for this case? It is sine of pi x, so e raised to power minus pi square t. You can see the same solution. Now you can check your answers whether which one is a satisfied. So your solution will be here. First one is u of t is 0. When it will be 0? It will be 0 only when sine of this 0 or this will be 0. So this part will be 0 when t approaches infinity, but this is my open interval, so it means this can never be 0. This part will be 0 when x is 0 or 1, but this is the open interval, so again this part can never be 0. Look at the second option, partial derivative with respect to t. So it is my minus here, this is minus pi square t sine of, again this can never be 0 because again of the same logic. E raised to power t and of is a bounded, so I can start from here. So what is that? This is 1 minus pi square t of sine pi x. Sine is always be less than of the 1 of here. So what is that? T is from 0 to infinity. So if I take t as a infinity, we all know 1 minus pi square value is less than 0 because pi is my 3.14. So if I take as a square, it is greater than of the 1. So whenever this part is negative, whenever t approaches infinity, it goes to the 0. That's a bounded solution. U is greater than 1, but we all know sine is always be less than 1. Because of this negative exponential, this is always less than 1. So product can never be greater than 1 is the right answer. Okay, look about this one. So which of the following is there? You can start from this case, dx, dy, dz. What is the coefficient of the p? That is here. What is the coefficient of the p? Is zx. Coefficient of the q is zy, and the constant is my y square minus x square. Now sometimes the student may think that how you can make them pair. There is no need to think about that. Look at the first option, x square. How you can make them x square? If you integrate them this, so if I take x into dx plus y square, so that is a plus y into dy plus z square plus z into dz. So you check whether it's a 0 or not. If I first multiply by z, x here, then y here, plus zy square minus zx, clearly see that it's a 0. So what is the meaning of that? X square plus y square plus z square divided by 2 is a constant I call as a C1. The first condition satisfied. Now look at the xy. When it will be xy? So if you take about this term, the derivative will be xy, d of xy. So it means I can multiply this by y and second term by x. So what will happen? This is the xyz, xyz 0. So from here we can see xy is equal to another constant. So both the constants are there. You can write the one constant C1 as the function of the C2. So first is the right answer. Now you can see this is the y minus x. How you can make the y minus x? Dy minus dx, but clearly say that this is a non-zero. So this option is cancel out. Look at the second and third. Now you can think about x plus, if I open this term, x square plus y square plus z square plus 2yz, 2xy, it is another constant, say a, for example a. So this part we already computed as a C1, xy already computed as a C2. So here, so this is my C1. So I can written C1 as a linear, as a combination of another constant, so which is nothing but my first part. So that's a correct state. So that's the answer are there. What is the second part? If I write this as y square plus z square plus 2xy, I call it as a b. So this is my C1 this is my C2, so I consider this as a B of f of C2, which is also the same, so this is also the right answer. So A, B and D are my correct option of this problem. Okay, which of the following is the solution? So which is a non-linear, so you can never solve by this manner, so you have to solve by using the Char-Pit method, but I will tell you the shortcut is for you. You can find the value of P from here. We all know what is the P, partial derivative with respect to x, partial derivative with respect to y is q. What is the P? 1 over a minus ay over x square. What is the q is? Partial derivative with respect to y. Fine. Now you can substitute here p q of x. If you multiply them, 1 by a, this a over x into x is here, plus q y of q square, it is a square x square. So can it be 1? If you multiply them, a square cancel out, a into a is 1, that is satisfied. Look at the another second case. When you take as this, it's a 1 over b, a y over x square, q is my a over x. Fine. So clearly say that when you multiply them in the LHS, it can never be 1, because you can see there is only difference, it's a b, but here is all not b. Look at the third case. 2zp is 4a, 2zq is my 4. So from here you can find the p as 2a over z, q as my 2 over z. So if you substitute in the given equation, you will get as p, q and x, p, q multiplied by x. So 4ax over z square and y of q square, so 4y over z square. If I take as a z square LCM, the numerator part is 4ax plus 4y, it is z square minus b, which is not 1, cancel. Look at the last option, z minus b of p is 4a, 2 times z minus b of q is my 4. Fine. So we can find the value of p, 2a over z minus b, q is my 2 over z minus b. So if I substitute in this given equation, what will happen here? P, q and this, so 4ax over z minus b whole square, 4y over z minus b whole square. So what is that? This is numerator is z minus b square, is 1 is the correct answer. So A and D are my correct answers. Okay, now you can see the coefficients are my constants, but here it is not guaranteed that it is a sine or the exponential. So we can start with the Lagrange equation. This is my here, this is 0, coefficient of the x is my a, coefficient of this is my. So from these two equations we can get as u is constant. From this equation we can say this is in terms of the t, this is x is at plus c2, so I can written as x minus at is another constant. So therefore I can see phi of u is constant as here. Fine. Now you can apply the initial condition. So phi of u0 is x is my here and this is my 0, so that is x. Or I can simplify that, I can return in this manner, that could be easy. Phi of this is my u0 of x. Fine. So now this is my u of x. I can apply this initial condition here. Phi of x minus 0 is u0 of x, that is phi of x is u0x. So I can substitute this value here. So u0 x minus at is my u of x comma t, that is my solution. So from here we can see u and u naught are same. So what is the following statement true? If u0 is bounded, so I can substitute the value of the u as u. So what is the meaning of that? U also bounded, but it said u is unbounded, so this is my false statement. Another second part is if u is equal to 0, if u0 vanishes, what is the meaning of that? U also vanish, because both are same and it also said is a vanish. So this is my correct statement, this is my false statement. So S1 is true, S1 is true, S1 is false, so both are there, it is typing error, is a false. So this is a false, this is my correct answer of this problem. Okay, now again you can see this is again the heat equation. So how you can write the solution directly? This is my sin x, and you can see from here C is my 1. Fine. So what is the A? If you compare them as the A is my 1, so it is my minus of t. What is the sine of 2x? What is the A is minus of 2, so minus of 4t. That's the solution of this here. First part is as t approaches infinity, the e raised to power minus t goes to the 0. This part goes to the 0, so therefore u goes to the 0. Second is t square of u. So when you multiply by t square, it can be written like of this, plus of t square of this. As t approaches infinity, the value of this, what is the value of this as t tends to infinity? So it's a infinity by infinity, so I can written this as of here, again infinity by infinity, so it goes to the 0. So this part goes to the 0, similarly this part goes to the 0, so this complete part goes to the 0. E raised to power t of u is a bounded, so I can start from here, I can multiply this sin x, e raised to power minus of t sine of 2x, which is less than 1, less than of this. Clearly says that whenever t is my greater than 0, that is whenever t approaches infinity, this part goes to the 0, so this is less than 1 is a bounded. Look at the last option. If you multiply by t raised to power 2 of this, the first part will be here and second part will be my here. So what is given to you? This goes to the 0 as t tends to infinity. When t tends to infinity, it goes to the 0, but this part goes to the infinity, so this can never be goes to the 0. So the right answers are A, B and C. Okay, look at this one. So in this case you can see none of the numerical information is given to you. It means there is no need to solve the problem, you just write the conceptual. This is the wave equation, so C is equal to 1. So what is the solution of the wave equation? So that is half f of x plus ct, f of x minus c of t, plus 1 over 2c x minus t x plus t of this one. Now what is given to you? Whenever x does not belongs to the 0, 1, then your f and g both are 0, otherwise no condition is given. Then so for the first case, minus infinity, 0, 0, infinity. So it's a Cartesian product. I can make the pair as here. Fine. This is the pair and this is the pair. Now for the first case, x plus t, this the first value is my x, second is t. When you plus them, it will be minus infinity. Sorry, you can't say. You have to check whether it belongs. So when you add them, it will not belongs to the 0, 1. It will not belongs to the 0, 1. It belongs to the 0, 1. It will not belongs to the 0, 1. So what is the meaning of that? When it does not belongs to the 0, 1, f and g are 0. So corresponding to this, f is 0, g is 0. So complete is 0, 0, non-zero, 0. So the final solution will be non-zero. Similarly for here, when you take the pair of the 1, 0. So 1, 0, when you take x is 1, 0, x plus t will be 1, which does not belongs to, which belongs to this. So again this part will not be a 0. Look at this pair, x plus t is less than 0. Fine. And you can see this is the value of the t. That means, what is that? What will happen if t is greater than 0? What is my x? Such that x plus t will be less than 0. So x must be less than 0. So what is that my x minus t? When x is less than 0, t is always positive. So this part is also less than 0. So what is the meaning of that? X plus t does not belong to the 0, 1. X minus t does not belong to the 0, 1. So this does not belong to the 0, 1. This does not belong to the 0, 1. So it's a 0. It's a 0. What is the g of u? It's a function of the x and t. So clearly see that it is a less than 0, which is not belongs to 0, 1. It is also 0 is the right answer. Look at the next case. X minus t is greater than 1. So t will be greater than 0. It is given to you t as a greater than 0. So once t is my greater than 0, what will be the pair of the x? Can you find the condition of the x? What is the x minus t? First of all, x is greater than 1. It means it does not belong to the 0, 1. Fine. So once it does not belong to the 0, 1, so u will be f will be 0. This part will be 0. What is the x plus t? When t is greater than 0, this will be here. Again, it will not lies between 0, 1. So again, this will be 0, this will be 0. The right answer is my C and D are the correct answers. Okay, this is a simple ordinary differential equation. That's a very simple task. Like, let's say, what is the shortcut tricks? As I explained you earlier in my previous video, you can solve them and get its value. What is the coefficient of the x? 4. Coefficient of y is minus 1. Substitute here. X square minus yy is minus 1. Is it 0? No. So first option cancel. Look at this, x plus 4y. If I put them as 0, x is minus 4y. Coefficient is 1. So substitute uxx, that is a x square, minus y is minus 4. Is it 0? No, 0. So this option is also cancelled. Look at the x plus 2y. X is equal to minus 2y. So I can substitute 1 minus 2 square. Is it satisfied? Yes. I have to check the second option also. X minus 2y, that's here. So 4 times 1 square minus 2 times square. Again is satisfied. This is the right answer. Look at the first option. I can substitute x as a 0. So it means y is nothing be there. So I can simply write as here. So it is 4 1 square minus 0 square, not be 0. So the only right answer is my B. I already discussed the several kind of the question here in my previous video. You can watch the previous year PY question on the partial differential equation. Okay, let f be the function such that partial derivative with respect to x, partial derivative with respect to y are same. Okay, so for all the functions, look at that, any function of the R scale. You can think about any function, say like of here, this satisfied. You may think of any of the function like x plus y, that's the simplest one. So in this case you can see satisfied. So look at that, this option is cancelled because this function is a non-zero. F of xy is f of minus xy. So what is the f of xy is my x plus y. What is the f of minus y comma x? It's a minus y plus x, which are not same. So this option also cancelled. A function is constant on the line x is equal to minus y. When you say x is equal to minus y, this value will be 0, this value will be 1. So in both the case we will get as a constant vector. So that is the correct answer. F of xy is minus f of, so if I consider this as a function, so x plus y, this is y plus x is equal to partial derivative by 1, sorry, this is a comma, plus y minus x of 1. So clearly say that 0 is equal to 0, satisfied. But if you think about here, it is e raised to power x plus y, e raised to power y plus x. What is the partial derivative? Same, and this is y minus x of same. So clearly say that this will be cancelled out, is the same, 0 is equal to 0, right answer. So the only function which satisfied this condition is of this form, only is x plus y r. Okay, look at that. Now again it's a heat equation, so we can find the solution. U is e raised to power iota kx plus omega t. Fine, where k is my non-zero constant and omega is constant. Okay, so the solution is a constant. Repeat itself, yes, 2. What is the meaning of the repeat is? It's a periodic, but you can see if you operate them as a cos plus sine and it's a function of the sine and cosine, it's a periodic, that's 2. It's a uniformly bounded. If you find the modulus of this, e raised to power iota of this, it is always less than equal to 1, it's a bounded here for all x. Now how you can think about the first and second options? Remain constant and amplitude decreases with the time. Firstly, k is my non-zero constant, so I can consider as a k1, k2 and k3. Fine. So if I substitute here e raised to power x is my here, k is my this, so k1 x1, k2 x2, k3 x3 plus omega t. Now since this is a solution, so it's satisfied here, so I again use the same approach as of this one, like of this coefficient of the x as here. So what is that? If I substitute in this, coefficient of the t is my iota omega, fine, is equal to x1. What is the coefficient of the x1 is iota k1, is just x1 square, iota k2 square and iota k3 square. So what will happen if you open this? It is minus of k1 square minus k2 square minus k3 square. Now you can equate the coefficient, real and imaginary part. Omega will be 0 and this part will be 0. But since it is a square value, so square value can never be 0, so it means it will be individually 0. Fine. So once k1, k2, k3 0, it means k is a 0. So you can substitute here. So u is 0, omega is also 0. So it means this is my 1. So that's a constant function. Fine. Now look at that, whether its amplitude decreases exponentially. So I can see from here, what is the iota omega? Iota omega I can substitute here. This is iota kx, iota omega. Iota omega is nothing but my minus k1 square here. So this value always positive, and because of this negative, it is decreases exponentially with the time. So this all are my correct option for this exam. Okay, look at this question. So you have to find the partial derivative y and with respect to x. Here this is independent of y. So once you take the partial derivative with respect to y, the answer will be 0. Now look at here. Firstly take the partial derivative with respect to x, it will be here. Then after that it's a minus of x plus y. There is no need to solve them, just think about the problem and get the answer in a quick manner. Okay, look at this one. So what is given to you is g is even, odd and so on. Okay, that's a simple question. I think initial condition is given to you as a x comma y square. So I can check this condition firstly at x comma x square, because they are talking about the function g, and g is dependent on the x and x square. So I can return this function as of this. Now at x comma x square, what will happen at x comma x square? What is the partial derivative of u? Is a g of x. Fine. So what is that? Partial derivative of g is a 0. What is the meaning of that? G is my constant. So g can be 1, g can be 2, 3, 4 and so on, and every constant function we all know is a even function. Fine. Why it's a even function? Because if I say this is my 7, so g of 7 is same as that of g of, so it's an even function. So the right answer is here. This is cancelled. Now look at the other options, whether u is satisfied or not. So if g is here, we can check about this third option. What is the value of the x comma x square? So 2 times y is my x square, so it is x. G of z is my constant, so I can consider this as alpha. So when the lower limit and upper limits are same, it's 0, so it's satisfied. Now look at this second option. If you take the partial derivative with respect to y, so you have to apply the Leibniz theorem. So how you can make them? Partial derivative with respect to y is nothing, so it is my y, g of root y, and partial derivative with respect to root y, and it is x, it will be 0. So what is the partial derivative of this is 1 by 2 root 2, so this will be cancelled out upon here, it is g of, so now add the value of the y, that is x square, it is my g of x. So it also satisfied, so both the conditions satisfied is the right answer. Look at the fourth option. What is the value at x comma x square? This is 2x x square, z constant is here, this. So what is the answer of this? Alpha is outside, z square over 2 from x to x square. Is it 0? It is not 0. x4 minus x square by 2, which is non-zero. So it means this condition is not satisfied. Right answer is B and D are the right answers. Okay, what is that? This is my Laplace equation. Fine. Now I already tell you the shortcut tricks for the heat equations, like of this when you have the form of the sin AX. Now what is the shortcut tricks for the Laplace equation? So firstly, look over the condition given to you. This, okay, whenever you have the Laplace equation, your solution will either of this form, sine hyperbolic n pi over ax sine n pi over by, or your solution will be sine n pi over ax and sine hyperbolic n pi over by. What is the a and b? A and b are the limits of the x and y. Now read the statement. It is given to you in terms of y, sine of y. So that means this is the equation form. So I can write the solution as of this: a sine, what is the a? Upper limit of this is my pi, so pi will be cancelled out, sine nx, sine b is again pi, so it's a ny. Fine. This is my solution. Now what is the value of the n? In this case n is 1, in this case n is 2. How you find the value of a? Again, a is very simple. You can apply this condition. Fine. So, or otherwise you can simply say it's a sine is already there. So we think about a as the coefficient of this, 1 over sine n x. What is the upper limit of the x is a. So what is that? So solution will be 1 over sine, what is the a? Pi. So it is n pi sine hyperbolic nx sine hyperbolic ny. This is the general answer of this Laplace equation. Now according to the question, what is the solution? Firstly we write here, in this case n is 1, so my solution will be sine hyperbolic pi sine hyperbolic x sine y, plus for the n is equal to 2, sine hyperbolic 2x sine of 2y divided by sine hyperbolic of 2 pi. Fine. Now look at the options, 1 comma pi by 2. So I can clear this screen for you because we get a solution here. Now I can write for you here 1 comma pi by 2. So x is 1. When y is equal to pi by 2, it's 1. So it is my sine hyperbolic 1 sine hyperbolic pi. And when it is pi by 2, it's a sine pi 0. So the answer is sine 1 sine hyperbolic pi inverse. That's the correct answer. Look at the 1 comma pi by 2, it's a wrong answer because inverse will be on the sine hyperbolic pi. It's cancelled. Look at the third option, 1 comma pi by 4. If you substitute here, x is my 1 sine hyperbolic pi. When y is pi by 2, pi is 1 by here. When it's a pi by 4, it's a pi by 2 is a 1. So sine hyperbolic 2x is 1 sine hyperbolic 2 pi. So look at that, sine pi hyperbolic inverse fine, sine hyperbolic 1 fine, 1 by root 2 fine, sine hyperbolic 2 sine is the right answer. So this is wrong because hyperbolic inverse is not there. So the right answer is A and C. Remember, this is the one of the simplest shortcut tricks for you. You can solve the couple of the answers within a 10 to 15 seconds. Again, you can see this is the Laplace equation again. Now here it is in terms of the sine 2x. So what is my solution? If it is a sine of the 2x, then hyperbolic will be my y is pi, so n pi. So n is my 2 because it is given as a 2 sine 2y divided by a is my sine hyperbolic. Upper limit of the y is my pi. Fine. Is it clear everyone how you can write it directly? Otherwise you can see this solution again. Now you can check your answers. Maximum of the u when x belongs to the 0 comma pi close interval, y 0 comma pi close interval. That's very simple. What is the maximum value of the sine 2 pi? 1. What is the sine maximum value of the y is pi, so sine 2 hyperbolic y is again 1. So product is 1, so is equality 1 satisfied. U of x comma is 1 for some x naught lies in the open interval, y lies in the open interval of this. So now you can see u will be 1 only when sine of 2x is 1 and sine hyperbolic 2y is over sine hyperbolic 2 pi is 1. But from here you easily see it will be 1 only when y is equal to pi, but pi is not belongs to this because it's open interval. Similarly, this value will be 1 only when x is 0 or is pi by 4. Fine, but you can see pi by 4 lies here, but once this number is not 1, if this even this number will be 1 but this number is not a 1, so what is the meaning of that? Product can never be 1, so this option is cancelled. U of x comma y is greater than 1 when it's open interval, so is a greater than minus 1. Fine. Sine of 2x is greater than equal to minus 1. Fine. Sine hyperbolic 2y over sine hyperbolic 2 pi is also be greater than equal to 1, but if you look about that, this is strictly greater than minus 1. Here is the equality. When the equality appears only at the x points p, equality appears only at the end point p, or you can see here this equality appears when y is equal to pi, but pi is not in the interval, so it means this can never be equality never 1. This once this number can never be minus 1, the product can never be equality. So what is the meaning of that? This is strictly greater than minus 1, so that's a satisfied. Look at the last case. In this case, x belongs to the 0 comma pi, y is also belongs to the closed interval 0 comma pi, and you have to find the minimum value. Again the same case. So in this case you will get as the minus 1 as the, because end points appear, but in this case it is said that it greater than, so that's a wrong answer. Answers are A and C are the correct options. Okay, look at this one. Again this is the heat equation. So but in the case of the heat equation, as I told you, you have to write the solution in terms of the sine ax bx, but there is no term involving of this case. So that's a very simple, there is no bother about that. If I write this equation as a plus bx plus of vx comma 0, there is no worry about that. Now if I think the solution of this form, a plus bx plus v of x comma t, fine. If I substitute the value as here, what will happen? If I substitute partial derivative with respect to t, this is a constant, it's a linear, so this is same as that of v. If you take the second derivative, it is again the same as that of this. So what is that? Again this is a heat equation but in terms of v. So how you can write this as, what is the v of this? So I can write the v as, I can multiply and divide by 2. Fine. So again in this case c is my 1, so my solution will be, what is the solution? E sine 2 pi x by 2. Fine. And c is 1, so 4 a square of t, 2 is the answer. So I can written this as 4 pi square t sine of 2 pi x is my v solution. Fine. So what is the final solution, the u? I can substitute here. So what is the a and b? If you substitute this value, you will get again as a 1 plus x and 2 plus, there is no worry about that. So 1 plus x plus half e raised to power 4 pi square t sine of 2 pi x. Now check about the answer. Half comma 1 by 4. When you substitute half, it's a 3 by 2. When you substitute x is half, it's a sine pi. Sine pi is a 0, so answer is correct. When you substitute x is half, y is equal to 1 by 2, so it is 1 plus x 3 by 2. Y x is equal to half, it's a 0, so again 3 by 2 is the right answer. When you substitute 1 by 4 and 3 by 4, if you substitute here, it is 5 by 4. When you substitute x is 1 by 4, it's a sine pi by 2, it's a 1, so half. When you substitute t as 3 by 4, so 4 will be cancelled out, 3 pi square, correct option. When you look about this one, it's a 5 by 4 plus half e raised power. When substitute x is equal to 1, 4 pi square. When you substitute x is a 1, so it's also be the right answer. So all these 4 options are the correct options for this particular exam. Okay, so this is the wave equation. Again, c is my 1. So what is my solution? Half. This is similar to the previous one but slightly different, because again nothing is given to you in terms of numerical, so we have to solve by the conceptual manner. 1/2 x plus c x minus g of u du. Now look at that. Whenever x is less than 0, f and g both are 0, otherwise this condition are here. So look at the first option. Whenever x is less than 0, t is greater than 0, u is always 0. Okay, how you can see that? Say x is 0. Firstly, I can simply take x is 0. What is my u? U is half. This is okay. No need of this. More generalized. Look at the x plus t. If x is less than equal to 0, t is my greater than 0. Can it be less than 0 always? Can it be less than 0 always? No. It may be greater than 0, it may be less than 0, or it may equal to 0. So what is the bet? But fx and gx are 0 only when x is less than equal to 0. But this is not always true. It means this is not always 0. This is not always 0. G is not always 0. So it means u is not always 0. But he said 0 for all x is not satisfied. Fine. Look at the second option. He said u is a bounded function whenever x belongs to the R and t is my 0 to infinity. So how you can think about that? So look at that. Whenever x belongs to my R, fine, x belongs to the R, and here, okay. So in order to prove u is bounded, I have to prove f and g both are bounded. Then the only way you can think about that. So look at that. Whenever t is my greater than 0, fine, and x belongs to the R, these two conditions, f is here, which implies that f is bounded whenever x is greater than 0. So it is satisfied. T is greater than 0. So if I see here, look at this option, 0 to infinity, because t is value from 0 to infinity, of g is also bounded. So f and g both are bounded. It means u is also bounded is the correct option. Look at the third option. X plus t is my less than 0. But t is always be greater than 0. So what is the meaning of that? T is my greater than 0. What is the nature of the x? X is less than 0, then only it will be here. So whenever x plus t is less than 0, it satisfied this condition. So f will be my 0. What is my x minus t? When x is less than 0, t is my greater than 0, so this number is also be less than 0. So that means this also satisfies this condition. F and g both are 0 in this case, because x minus t less than 0, x plus t less than 0, so this value will also be less than 0. So satisfied, 0 is the right answer. Look at the last option. When you consider x plus t as greater than 0, what is the meaning of that? X plus t does not belong to the 0 1. Fine. So that means in this case, this is the case, whenever x is greater than 0, x plus t is greater than 0, this means this is my greater than 0. So f of x is non-zero, because you can see that f is strictly greater than 0. X minus t is also greater than 0 or not? As t is my greater than 0, so x minus t, it can be greater than 0, it can be less than 0, because if I take this is 7, if I consider x is my minus 9, so it will be negative. If I consider x is my 11, it will be positive. So it means this portion, it may 0 or may not be 0. but he said always 0 is cancel. So that is not always true. So the right answer is second and the third are the correct answers. Okay, these are the correct options are there. So you can start from the here dx, dy, du. Coefficient of the x is my u, coefficient of y is my here, this is my x. So if you start from the first and second pair, you can see x dx minus u is my 0. So that is x square minus u square over 2 is my here. Or you can say u square minus x square is constant. Fine. Second, you need x plus u. How you can make the x plus u? I can write as x plus u, that is a dx plus du. What is the answer of the x plus u? U plus x. So I can equate them with respect to y. So what is that? This is log of u plus x. This is log of yc, or c I can written as u plus x over y. So there are two constants. So I can written this number as u square minus x square, and I need a y over this, so I can take as a reciprocal. I can another constant y over u plus x. So the first option is correct one. Second option is also correct, because we all know once you have the two function, we can return the first function as a combination of the second some function. So this is y over u plus x. I can take x square as this side. It is a u square plus x square, but clearly say that u square plus x square can never be 0. Why? Because in order to make them u plus as 0, I need to start from here. Is it 0? No, because if you multiply this by u, it's a ux, it's xu, but it is not 0. How you make them x plus y? If you start from the dx dy, is it 0? No. So it means this option is also cancel out. Correct options are A and B. Okay, it's a unique solution, no solution, infinite many solutions. So we can start from again this case. Right hand side is 0, coefficient of this is 1, this is 1, this is my 0. So if I consider x is my t, y is my t, u is my 0. But here you can see is an undetermined form. So it means this you can't identify that whether it's a unique solution or infinite solution. So in that case, you have to solve by the Lagrange equation 1, 1. So from the first two equation, you can see x minus y is equal to c1. From here, you can see y is equal to c2. So what you can do, how you can simply write this equation as a function of the others. So you can simply write as, what do you think that you can simply say as u is phi of x minus y. Now substitute u of x comma x. So this is my 0, this is x minus x, that is a phi of 0 is 0, that is phi of a is here. So I can say this is my 0. So u is 0. So that's a unique solution. It form a correct straight line as a characteristics. What is the meaning of the characteristics is you have to solve the equation like of this. Can you get a straight line from here? Yes, this is a straight line. So that's the right answer. U vanishes at the point 2, 1, but u is always 0. So that is my right answer. It has infinite many solutions, wrong answer. Remember, it is a unique solution for the different pairs of the x and y. There is a different x and y, but the solution is my u, not the xy. So the solution is not infinite. Pairs are infinite. So the right answers are A, B, C. Okay, in this case, we will see again the unique solution. Here we will set about here x, y, and here. So if I consider x is my t, y is my 1 minus t square, and u is my x is here. I can substitute here. So I can take the derivative, but here is x also, so I can substitute x this. So it will be t 1 minus t square and 0. Now take the derivative of x, 1. Derivative of this is minus t over 1 minus t square, it is 1. So if I open them, it is minus over t, it is 0. It is not equal. Once they are not equal, we will get as a unique solution. So since it's a part C, it may have more than one correct option. So a solution for all x, wrong answer, because we get a unique solution. How you can get the bounded and unbounded? So that's again a very simple. We will try to solve the equations by Lagrange. Dx, dy, du. Coefficient of x, this is y, this is 0. Fine. Now how you can solve that? Now you can easily solve this equation. This is in terms of, we can start from the first. This is x over y is my constant. From here you will get as a u2 is c2. Fine. Now how you can solve this equation? So therefore you can say u is my phi of x comma y as a linear combination of this. Now you can check about here. So on this condition, this is x. I can take x is t, y is my 1 minus t square, so u is my t, so I can substitute here as my t. So what is that? This is my t phi, this is t over. Fine. So how you can simplify them? I can consider a is my t over 1 minus t square. So what is the value of that t from here? I can make as a scaling. This is my t square. So what is the value of the t square? So this is t square over, it is how can I can a square, this is a square plus 1 of t square. So t will be my a over 1 plus a square. So I can simplify here as phi of a. So t will be my a over 1 plus a square. So therefore I can substitute here. U is my u, phi is a, that is a is my x over y divided by 1 plus x square over y square, which is x over x square plus y square. Now for the bounded you have to find the modulus. So I can return this number as x square over, what is that? This is always less than equal to 1. So that means it's a bounded also. It is unbounded, that's a cancel. Right answers are B and C. Okay, look at this another one. So again there is no uniqueness, so we will start from here. Dx, firstly we can check whether x plus y is 1 satisfied, all satisfied. So this is dz. Coefficient of x is here, y, this is z. So from the first two pair we can see x over y is equal to constant. From the last two pair we can see y over z is my c2. So I can take as a pair of this, y over z is phi times x over y. Now I can substitute here. Z is my 1, so y is my phi over here. I can take x is my t, so y is equal to 1 minus t square. So 1 minus of t square, phi of t of 1 minus t square. Again I can consider t is my 1 minus of here. So I can find the value of t, I can scaling them, so you will get a as of this. So therefore what is that? This is phi of a. What is the 1 minus t square? It is 1 minus a square over this. So what is that? This is 1 over here. Fine. So I can substitute this, y over z, this is equal to phi, that is x over y. So 1 plus x square over y square. So you can simplify this, y is upside, x square plus y square, y over, y will be cancelled out, so z will be my here. So that is the fourth option is the only right answer of the problem. Okay, look at the Charpit equations. So whenever there is a Charpit equation, you always try to find the dp. What is the coefficient of the dp? Is always fx plus p times f of z. What is the f? Is given equation p plus q minus of pq. So if you take the partial derivative with respect to x, is a 0, partial derivative with respect to z is a 0, so it will be the 0, but here is a non-zero, so this option is cancelled. Fine. Similarly, how you can find the value of the dq? It is partial derivative with respect to y, partial derivative q of here, again it's a 0, satisfied, but this equation not satisfied, this is a cancel out. Now the equation is p plus q minus ab. So whenever, as I told you in my previous video also, whenever the partial differential equation of this form, then the solution is always in this nature, always in here, where P is equal to A and Q is my B. I can substitute here A plus B minus AB is equal to 0 here. So what is the value of I can find the value of P, that is A. What is the A? A is B over B minus 1. So that is P is B over is the correct option. So if I substitute value of A here, this is B over B minus X plus BY plus C is again the correct answers. So now a solution of the Char-Pit equation. So when it will be the Char-Pit equation, it will be 0. So clearly say that when you equate these two equations, from here you can see Q is my constant because dq is 0. So this is my constant. So the right answers are B, C and D are my right equations. Again this is a Char-Pit equations. So what is the solution is P square plus Q square minus 1. So firstly again we will check about the dp fx p fz, again 0, but you can see dp is a non-zero, so this option cancel. dp is a 0, correct. We can find the dq fy plus q fz, again 0, satisfied. What is the coefficient of the dx? Minus fp. Coefficient of the dy? Minus fq. Coefficient of the du multiplied by p multiplied by q. So we can check it. Fp 2p, satisfied. Minus of 2p. This is minus of 2q multiplied by p, and here it is minus of p square plus q square. It is 1. So it is a minus of 2. Minus will be cancelled out. So all are satisfied. Right answer. How you can find the solution? So once you know this is a solution, yes, again you can see, yes, so again you can see it's a function of the, so P and Q is my constant. Okay, so you can see the solution is ax plus by plus c, and from also a square plus b square minus 1 is 0, or a will be 1 minus b square. Fine. Okay, how you can find the value of the a or b? How you can solve that? That's again simple. We can substitute this value with respect to a as a 0. So what is that? I can substitute the value b here firstly. So firstly, what is the z? 1 minus b square of x plus by plus c. So I can take the partial derivative b with respect to 0. Minus b, 1 minus b square of x plus y is equal to 0. Fine. So I can see from here, this is y over x is b over 1 minus b square. Fine. Now how you can think about the rest of the part? There is a one constant as a c. Now you can see about this condition. What is given to you? U is my 0. U is my 0 on x plus y is equal to 1. So you can think about any of the pairs, say 1 comma 0, 0 comma 1, that's the simplest form. So I can substitute this value as here. When u is 0, so this is my u. So when u is 0, x is 1, y is 0, so this is a plus c. On the other hand, this is b plus c. So from here you can see a is equal to minus c, b is equal to minus c. Fine. But we know what is the meaning of that. A is equal to b, and once a is equal to b, you can substitute here. You will get a b as 1 by root 2. So what is the solution of this problem b? So a and b are same, x plus y over root 2. What is the c? C is nothing but my minus of a, so it is minus 1 over. So now you can substitute this 1 comma root 2. 1 comma root 2 is my root 2. 1 comma root 2 is my 1. So this option is correct. This option is cancelled. So the right answer is my B and D are the correct option. Now again this is the Char-Pit equations. I can firstly write for you here x p square y q square x plus y of pq minus u times p minus u times q plus 1 is equal to 0. This is my f. Now look at that. You can see the first pair are not same. What is the coefficient of the x? As I tell you, this is the minus partial derivative of the p. What is that? 2xp. This is the p, x plus y of q and minus of u. So this option is cancelled. Is it satisfied? Yes. What is the coefficient of the dy? Minus f of q. So if you take as a 2yq, yes, this satisfied, minus u satisfied. What is the dp? You can see this is fx plus p times fz, or in this case is a u, f of u. So what is the fx? P square plus pq. What is the partial derivative with respect to u? Is p plus q. Fine. This is the solution of this. So is it a 0? P square is minus fx plus of this. So this is a minus of this. So clearly say that this is a 0. Similarly, you can get as 0 also. How you can do that? If you multiply this by p, this by q, you can add them. You can see here. So this is the satisfied. Now look at the first two options. How you can see that? Do you remember any of the equation, PD equation, whose solution is here? So either if you prove this is my here, or you can prove the Clairaut's equation. What is the Clairaut's equation? Is px plus qy plus function of the pq. Then the solution will be of this nature. So let's see this one. Can you simplify this? If I open this bracket, if I take as a xp common, this is p, xp common plus q. Fine. From here, if I take yq common, it's a q plus p. From here, it is p plus q is plus 1 is 0. So p plus q is common throughout. So yq minus u is minus 1. So can you find the value of the u from here? P plus q. So I can divide by p plus q here. So u will be px qy plus 1 over. So which is of this nature? Px qy function of the p and q. So the solution of this will be ax by function of a over b. So 1 over a plus b is the right answer. Look at this case. It is also ax plus by, but it's a function. The function could be anything. It could be sine of ax plus by. It could be exponential of ax plus by or logarithm of this. But we need only the linear form. So this is not the general equations. So the right answers are A and D are the correct options. Okay, look at this equation. So again, this is the linear. We can start with the Clairaut. This is the first method. I will tell you the second method also here. So dx, coefficient is x plus y of z, x minus y of z, x square plus y square. Now again, how you think that? Look at the option. When it will be x square, you have to think here. Plus y square, you have to think about here. Plus z square, plus z of dz. So check whether the denominator part will be 0 or not. If you multiply this by x, it is x square z, xyz. Multiply this by y, it is xyz, y square z. Multiply this by z, x square z plus y square z. Clearly see that this will not be 0. So it means this solution will not satisfy. This is a cancel. Look at the second option. This is x dx, y minus y square is a minus dy minus z dz. So this is minus, this is minus. Okay. So you can see this will be cancelled, this will be cancelled, this will be cancelled. It's a 0. So if it is a 0, it means x square minus y square minus z square is one constant. So look at here also. Z square, how you make them z square is a z of dz. How you make as a xy? So xy will be only make when you take y dx and x dy. Fine. So now you can see, multiply this by z. So zx square, zy square. Multiply this by y, xyz, y square z. Multiply this by x, x square z, xy z, and subtract them. It's a negative, it's a negative, it's a negative, it's a positive. So x square z cancel, this will be cancelled, this will be cancelled here. So once you integrate them, you will get as a z square by 2 minus xy is equal to constant another. So from here you will get this as a right answer. Similarly, you can check about the third option, x plus y plus z. Can you make this value will be a 0? No. So it means this option cancel out. X cube, how you make as x cube? D square x minus y cube. Z cube, how you make this? So how you make them? Multiply this by x square, this by y square, this by z square. Again it will not be 0, because once you multiply this it will be x cube, but there is no term of the x cube, it is not 0. So this option is also cancelled. Okay, this is again the characteristics curve. So whenever there is a characteristics curve, you have to find the b square minus 4ac. How you find the characteristics curve? Firstly, the characteristics curve is my here plus lambda. Fine. And what is the lambda is? Lambda is the root of lambda a square plus b lambda plus c is equal to 0. So from here you can see a is my minus y, b is 0, c is 1. Because in this case they are not talking about the elliptical, hyperbolic, parabolic. You can substitute here. This is y square plus 0 plus 1 is 0. So the lambda will be my 1 over y square. Oh, sorry. It is quadratic in lambda. It is a lambda square. So this is minus y here. So it will be, so what is the value of the lambda will be my plus minus 1 over. So y characteristics equation of here is this, or I can written this as equality plus minus of this. Now check that 2 family of the curve when y is less than 0. When y is less than 0, this part is imaginary, but they are talking about the real. Cancel. Whenever y is greater than 0, there are no real roots, but we will always get a real roots. This option cancel. Vertical line when y is equal to 0. So check that. When y is equal to 0, what is the meaning of that? Dy by dx is 0. That is the slope is 0, or sorry, infinity. It means dx by d is 0. That means if you integrate them, x is my constant. So how you draw the line of the constant? This is the line of the x constant. That is a vertical line. Correct answer. Branches of the quadratic curve when y is non-zero. When y is non-zero, it can be imaginary, it can be real. So it means it can never be quadratic. Moreover, if you solve like this way, if you integrate them, it is my 3 by 2. Again you can see this is not quadratic. It's a y raised to power 3 by 2, but he said quadratic. Not answer is there. So the right answer is only C is the correct option of the problem. Okay, they are talking about the elliptical, parabolic, so we have to find the b square minus 4ac. What is the my b? X, y 0, a is 1, c is my x. So it is my minus 4x. So how you can find the solution? It is a parabolic, hyperbolic, elliptical. Parabolic only when x is equal to 0, because we need a 0. Hyperbolic we need a greater than 0. Elliptical we need a less than 0. So when it will be greater than 0? When x will be less than 0. Less than 0 when x will be greater than 0. Elliptical when x is greater than 0. Correct statement. Hyperbolic when x is greater than 0. Wrong statement. Elliptical when x is wrong. Hyperbolic when x is here. So A are the correct answers. Consider the 4 partial again are the hyperbolic, parabolic and here. You can open the bracket firstly. So this is AC UXX. These are given to be a differentiable function. So once any of the function is differentiable, it means these are the continuous also. And once we know by the Young's theorem, this is same when it's a continuous differentiable function. So I can open this bracket ED plus BC of UXY plus BD of UYY is my 0. Then how you can check that? This is my A, this is B, this is C. So we can start from the B square minus 4AC. ED plus BC minus 4 ABCD. So what is that? If you open this bracket, this is nothing but AD minus BC whole square. So now you can check the cases. Is it equal to 0, less than 0, or greater than 0? Since it's a greater than 0, it can never be less than 0. It means it can never be a elliptic. Fine. Is it always 0? This is not always 0. Always only when AD is equal to BC. Then only. Otherwise, we can say it's a greater than 0. So look at that. This is always hyperbolic, but it is not always hyperbolic because whenever AD is equal to BC, it's a parabolic. So cancel. Always parabolic, not true, because whenever AD minus BC is a non-zero, then it is a hyperbolic. Never parabolic, that's a wrong statement. Whenever this condition is satisfied, it is here. Never elliptical is the right answer. So look at that. If I consider all as A, B, C, D as a 1, so this will be 0. So it's a parabolic, but instead never parabolic. So the right answer is only D is the correct answer. Okay, again they are talking about the elliptical, hyperbolic, parabolic and so on. So what is my A? XX, P, B, e raised to power x square plus y square, C is my Q. Then we can start from the B square minus 4AC, B square, this is my B square, minus 4PQ. Now look at the first case is elliptic. Okay, we can start in the general manner, either greater than, equal to or less than 0. Fine. So I can solve this portion. X square plus y square is a 4PQ is right side, 4PQ, because it is for all the choices. So it is a constant. I consider this as say K. Fine, because the solution will not involve P and Q. Take the logarithm on the both side. So 2 times x square plus y square is greater than, less than or equal to log of K. I constant as a C, divided by 2 on the both side. So x square plus y square either greater than, less than, I consider this as a R. Now look at the options. Elliptic, when it's a greater than. So when it is a greater than, it means all the signs are greater than. So when it will be greater than, we will call as the hyperbolic. So first option cancel. Hyperbolic when greater than, correct. Parabolic when greater than, false. Hyperbolic when less than. So when it is a less than, it is elliptical. So it's a cancel out. Right answer is my B is the correct option. Which of the following is not parabolic? It means once you find this condition, if this is non-zero, then it's a non-parabolic. A is my x square, B is my 2x, B is my 0, C is my 0, because it's a partial, it's a single derivative. So what is the B square minus 4AC? Is it correct? Yes. What is the B square minus 4AC? 0. B square 4AC is my 0. So this is my here. No, sorry. It is wrong. You have to, you have to compare by here. UXY, CUYY. So here A is my 0. This is a coefficient of the XY. So B is my x square, C is my 0. So what is the B square minus 4AC? For the first case, x raised to power 4, which is non-zero for all this range. If I consider x is minus 1, so it is a non-zero. So it is a non-parabolic. Look at this case. A is my x square, minus 2xy, B. A is my x square, and this is my y square. So 4 square 0. It's a parabolic. It's a wrong option. Again, this is a 4x square y square. 4x square is a parabolic. This is my B. This is my C. This is my A. Again, it's a parabolic. So the right answer is only A, which is not a parabolic. Okay, this is a question as I discussed earlier. Is a even that here are the both are the correct answers as I discussed earlier previously. Okay, which of the following is the solution of this? There are the two methods. Firstly, you can check which of the following not satisfied. At t is equal to 0, this is 0, this is 1, x satisfied. This is 0, 1, 1 satisfied, all are satisfied. Now, there are the two methods. Firstly, you can check about the options like here. If I consider my first option here, what is the u of t? If I substitute here, this is the same. What is the partial derivative with respect to x? E raised to power t. u is my e raised to x into this. Can it be a 0? No. It is my 1. It's a 2x e raised to power t minus 1, but we need a 0. So this option cancel out. Look at this option, u of t. This is my u of t. What is the x? U of x, partial derivative is 1 plus u. U is my here. Can it be a 0? No. So again this option is cancelled out. Look at these two options. Because it's a part C, it may have more than one correct options. So firstly I can open this bracket. This minus e raised to power minus of 2t plus e raised to power here. So partial derivative with respect to here. So it is this minus plus 2 times minus of this. This is a partial derivative with respect to t minus partial derivative with respect to x. Only the first term will be there plus u is the complete here. Now you can see whether it will be 0. You can see minus of the x plus of x cancel out. 2 plus it is a minus of this and it is also minus. So it's a 2 times cancel out. It's a minus, it's a plus, it's a cancel out, it's a 0, so it's a right answer. Look at the first option. Again, if I open this bracket, it is x e raised to power t, e raised to power 2t, and here. So partial derivative with respect to t, x e raised to power 2t minus of this is x minus partial derivative with respect to x is here plus of here term. Now check whether it will be cancelled out or not. E raised to power x, it will not cancel out. So once at least one of the term is not cancelled, it means it will not be 0. That's the right answer of the problem. Okay, the solution will be existence or not. So how you can check it? Again, it's a very simple. You can start again you can see the initial condition is x, not in the exponential of the sign, or moreover constant is not there. This is minus u 1 0. Fine. So from this case you can see u is equal to c. From this case, from the first and second case, how you can solve that? From the first and second case, how you can solve that? U is equal to constant. So if you substitute here, because if you take first and second, again you will get u square by 2 is a constant. That's the same thing. So if I substitute, u is my here minus c dt over 1. So what is that? It is c is equal x is equal to minus of ct plus another constant. Fine. This is the solution. Now I can written as c is my u, so x plus ut is equal to c2. So this is the first solution. This is the second solution. So how you can write that? Phi of x plus ut is equal to u. Now you can apply the initial condition. U of here, so phi x, t is my 0, u is my x. So phi of x is my x. So I can start from here. So x plus ut is equal to x. So x over 1 minus t is equal to u. This is my solution of the problem. Now solution exists for all t, cancel, because at t is equal to 1 solution does not exist. Solution exists for all t less than equal to half, correct, and breakdown. Breakdown means goes to the infinity, wrong. Solution exists for all t less than 1, satisfied, and it break down at t is equal to 1, satisfied, not 2. So the right answer is only third is the correct option. Okay, look at this one again. So again you have to solve this condition. There are two methods. Firstly, you can take the partial derivative here, you can satisfy this, otherwise you can solve like of here. So minus of x dt over 1 du, because it's the right hand side, you have to make them on the right hand side is a u minus 1. So from the first two case, you can see it is a log of x is t plus log of c, for example. So I can take as a common. So x is x over c, or you can say xc is e raised to power minus t. So c1 will be my e raised to power t over x. This is the first constant. Look at these two pairs. If you integrate them, your t is log of u minus 1 of c. So I can say u minus 1 of c is e raised to power t. Second constant is e raised to power t over u minus 1. Now both the solutions are there. You can start with this phi of e raised to power minus t over x is my here. Now once you written the solution, now you can use this initial condition ux comma 0 is gx. So phi, what is that? T is equal to 0, so e raised to power 0 is 1, so 1 over x, e raised to power 0 is 1, u is my g of x minus 1. So if I consider this as a, so a is my 1 by x, so x is 1 by a, so I can substitute here, this is 1 by a minus 1, so I can substitute here. Phi is my 1 over g, 1 over a, so a is my reciprocal of this, x over e raised to power minus t minus 1 is here. Fine. Now you have to find the solution of the u. So find the value of u. So I can say u minus 1 e raised to power t. I can written this as x e raised to power t minus 1. Is there any solution here? And u will be 1 plus e raised to power t of this. So 1 minus cancel out, 1 minus cancel out, 1 here. This is not true, it's a 1 minus, but it's a g minus, so it's a none of these is the right answer. So right answer is my here. Okay, so look at the another one. So again it's a linear, so you start from here dx dy du. So what is that? Coefficient is x, coefficient is y of u, coefficient is xy. Fine. Now nothing is given to you in the relation. That's a very simple. You need a xy. Fine. So I can think about how you can think about that. You can get a solution in a simple manner. That is not a big deal. That's a very simple target. So you just think about how you can make a yx. So you have to make x dy, y dx. So if I start from here plus x dy, what will happen? That is a yx, it is my yx, it is my xyu, so it means xy is common, 1 plus u, and it is xy is there. So if I multiply this term by u of du, what is the answer of this? It is xy, because if I multiply this by u of, so it will be xy. Now how you can make them? I can equate this term with the xy here. Fine. Xy will be cancelled out. Now you can integrate them. The first two terms will give you my xy. This is my u square by 2. The right hand side is my minus of u plus of c. So I can substitute the value at here. So xy is my 1. I can find the value of this. 25 over 2 minus I can take as a plus is my c. So what is my c? So it's a 6, 12 plus 25, that's a 37 over 2. So I can substitute here u square plus u plus xy minus 37 over 2. Fine. Now your target is to find the value of u, but it is a quadratic in u. How you can solve them? That's a quadratic. So you can simplify it. U square plus of 2u plus 2xy minus of 37 is 0. So which is a quadratic in u? I can get the solution as of this b square minus 4ac, 4ac over 2. So I can written this as 4 I can common, it will be cancelled out from the denominator. So it will be 138 minus 2xy. That is my solution. Now when it will be the solution exist? So clearly say the solution exists when this is my greater than 0. What is the meaning of that? Xy must be less than of 90. So my solution is uxy is minus 1 plus minus of 38 minus of 2xy. So whenever xy is less than equal to 19, the solution exists, and uxy is equal to yx, then you can easily see that because of the symmetric, so the solution exists. This is not that. Now from the third and fourth option we can find their solutions. I can find the solution at here. What is the value of the u1 comma 11? So minus of 1 plus minus of this, so I can take as a plus sign only because both the values are positive, so it's a plus sign are there. Now 38 1 comma 11, so it is my 11 to 22, so it is my x into y, it's 11 into 2 22, so it is my 16, so 16 will be my 4, 16 is my 4, so 1 plus minus 3 is my 3. If I take as a positive, it's satisfied. I can check about the 13 comma minus 1, so it is minus 1 plus 38 2xy, so it's a plus 26, so it is my 64, it is 8, 1 plus 8 is my 7 is the right answer. And clearly say that we already proved uxy is equal to uyx, but it is not equal to 3, so that option is wrong. Answer is A and C are the correct answers. Okay, look at this next option. So this is in terms of the exponential, but you can see the coefficient are not constant, so then you have to start with the Lagrange multiplier, Lagrange equation. So this is 0, coefficient of x is 1, this is x square. Now you can easily solve this, cross multiply and integrate them, you will get as a constant. From this case you can get as a C2 is 0. So what is that? So I can see u is phi of x cube by 3 minus of y. Apply the initial condition, u is e raised to power x cube over 3. So if I consider a is my x cube by 3, what is my x? 3a raised to power 1 by 3. So this is phi of a. I can substitute the value of x is 3a raised to power 1 by 3. Now substitute here. This is my a. This is phi of x. So this is e raised to power 3a. So x cube minus 3y raised to power 1 by 3. So this is the right answer because this is the part B, only one correct option, so C is the correct answer. Okay, look at this next option, next question. Okay, so it is exponential, but it is not in the solution form. But if you think about that, if you take the derivative, it will be, so if you multiply this by here, it's a constant. So it means you can work about this problem in this manner. This is a function of the x, so I have to take this as a function of the y. So I can take this firstly y, this is phi dash e raised to power 1 by x. If I take now it's a uxy, so phi dash e raised to power 1 by x minus of the x square. So I can see x square of this is a function of the y only. This is minus phi dash e raised to power x. Now I can substitute here, minus phi dash e raised to power 1 by x plus 3y square, u is my e raised to power 1 by x of the phi is 0. E raised to power 1 by x is cancelled out, so phi dash is equal to 3y square of phi. Make sure phi is a function of phi, so this is all terms in the y. If any of the terms is in terms of the x, then you can never solve it. So how you can solve? You can divide it by this, integrate them, it's a y cube, it's a log of y, so y is my e raised to power y cube. There is no need of the constant because we already imposed the initial condition here. So what is my solution? Solution is e raised to power y cube into e raised to power 1 by x is my solution. Now whether the PD is a linear or non-linear, because of this non-linear nature, it is not a linear. Separable method is applicable, yes, because you can see this is the function of x only, this is the function of the y only, so you can see it's a separable, so the method of separable is applicable. Now you can find the value of the u1 comma 1, it is 1 e of square is the right answer. So B and D are the correct options. Okay, look at this another question. So this is the question February 2022. You can solve this again in a very simple manner. What is given to you? Again, u is given to you in terms of the sine and cosine, but you can see constants are these are not constants. So you can see dx over minus x, dy over 1, du over, I can make them as the right hand side is a 1 minus u. So from the first two pair I can see this is minus of log x is y plus c, or I can see is a log of c if I consider this as a log c, for example. So this is xc is e raised to power minus y. So c1 is this is my first solution. Fine. From these two solutions we can see y is equal to minus log of 1 minus u into c. I consider c as a log of c. So e raised to power minus y over 1 minus u is my another constant. So I can make them in terms of the solution. So this is e raised to power minus y over 1 minus u is 5 times e raised to power minus y over x. Fine. Now substitute the initial condition, y is equal to 0. This is my u, x is here. So y is 0, 1. This is 1 minus sine x. This is phi of 1 by x. Fine. Now how you can solve this equation? So again I can consider this a as 1 by x. So x will be my 1 over a. So I can substitute here 1 over, this is x will be my 1 over a, phi of a. So I can substitute this value here. You can see what will be the answer, e raised to power minus y 1 minus u phi. So this is 1 over 1 minus sine 1 over a, that's a reciprocal of this. So x e raised to power y. Now you can substitute the value at the point 0 comma 1. X is 0, y is 1. So this is 1 over 1 minus sine, y is equal to 1, x is equal to 0. So it's a 0, sine 0 is a 0. So this is my, so where is the mistake? Sorry, it is y is equal to, so it's e raised to power minus 1. So sine 0 is 0, so it is a 1. So 1 over e is 1 minus u. So what is my u? This is the right answer of the problem. Okay, this is the, again, what is that? This is the wave equation with c is equal to 1. So what is my solution is half f of x plus ct and f of x minus ct plus 1 over 2c integration of the 0, that's a partial derivative is 0 by here. Then your target is to find the value at half 5 by 4. So I can substitute here. What is x plus t? 7 by 4, f of 3 by 4. Then what is the f of x? This is a pair. So 7 by 4, 1 minus 7 by 4 is minus 1 by 4. Minus 3 by 4, 1 minus x is 7 by 4. So it's a 21 by 16, minus 21 by 16 minus 21 over 16 of 1 by 2. So it is minus 21 over 32 is the, right, so 42, sorry, 42 over here. So you can divide it by, why is a minus sign? Because none of them is a minus. Is there any correction error? So it's a 1, 7 by 4, 1 minus 7 by 4 is minus 3 by 4, that's correct. Minus 3 by 4, it's minus 3 by 4, and 1 minus 3 is 7 by 4, that's correct. So where is that? Okay, if I ignore this, it's a 20, 16. Where is the mistake? 21 by 16, because none of the answer is there. So okay, we will check it again. We can solve it again. We will see about this property. I can write this function as f of 1 plus x. I can written as 1 plus here. So this is f of 3 by 4, and it's a negative. Oh sorry, I can never use this as minus 3 by 4, 1 minus 3 by 4, because it only applicable when x is 0, 1, but it is not a 0, 1. So I can make this as a 0, 1 from here. So this is x. So this is f of 1 plus x. X plus 1, it is a 1 by 4. Now again both the values are 0, 1. Again this number is not belongs to the 0, 1. So I have to make as a 0, 1. Now you can substitute here 3 by 4, 1 minus x 1 by 4 plus 1 by 4 f 3 by 4. So what is that? This is 3 by 16 plus 3 by 16 of 1 by 2. Answer is 3 by 16 is the right answer of this problem. So you can see 3 by 16 is the right. Make sure that this condition is important, that 7 by 4 not belongs to this. Okay, look at the last question about this. So which of the following is my solution of the Laplace equation? Now one solution I given you as a Laplace equation in terms of the hyperbolic. This is applicable only when this some initial condition is given to you, but this is not given. So what you can do, consider this as say u. Take the second time derivative. Firstly we can take the first time derivative 4x y cube, then uxx is my 20x cube plus 4y cube. Similarly you can take the partial derivative with respect to y, 6x square y square 5y raised to power 4, uyy will be 12x square y 20y cube. Clearly say that the sum will never be a 0. If you add them, will never be 0. This is cancel out. Look at the second option, x square plus of this. If you take the second derivative, it's a quadratic, it's a 2, uyy will be minus of 2, and see the sum will be 0 is the right answer. Look at the third and the fourth options. Either there are two methods. Either you can find the first derivative, then you can find the second derivative uy and uyy, but that will take some lengthy calculation. The easiest way, as I told you earlier, how you can solve that, I can write this in terms of the sign and exponential. So I can write this as e raised to power iota y, e raised to power minus iota y over 2. Fine. This is e raised to power x. I can return this number as minus e raised to power iota x over 2 and e raised to power y. So if I just open this, it will be x plus iota y, and it is x minus iota y divided by 2. It is iota x plus y, iota x plus y. Fine. Now we can apply the same trick like of this. We can take the first function as a 0. So what is that? X is equal to minus iota y. So coefficient of the x is 1. We can substitute here 1 square. Coefficient of the y is minus iota square. Is it 0? 1 minus iota square is minus 1, 0. So this satisfied. Look at this case. If I take x minus iota y is 0, x is equal to iota y. So it will give you as here. Again it's satisfied. If I think about here, iota x minus y. So if I substitute x is iota square and this is minus 1 square, again it's a 0. It's satisfied. If I put up this as a 0, it will give you iota x is y. So if I substitute here x square plus y coefficient is there, again it's satisfied, 0. All satisfied is the right answer of the problem. Now look at the last option, how you can check this. So you can see the solution will be u1 plus x. I can return this as of here. Fine. Again the first method is you can find the uxx and uyy, but you can see there is a square, you have to take the u over v. That's a lengthy calculation. But what is the shortcut tricks for you? You can write this equation in the polar coordinates. What is the polar equation of the Laplace equation? That is a urr plus 1 over r ur plus 1 over r square of u. This right hand side is 0. So I can make this as a polar form. So how you can make? I can take this is my r cos theta and y is equal to r sin theta. So my u will be, so numerator is r cos theta, denominator will be r square. So 1 will be cancelled out, it is my here. Fine. Now rest of the part is very simple. You can do as a first partial derivative with respect to r. This is r square. You can take the second derivative, it's a 2 cos theta over r cube. Now you need a u first derivative minus sin theta over r. You can take the second derivative minus cos theta over r square. Now you can substitute here. What is the urr is? This one, 2 over r cube cos theta plus 1 by r of u r. So it's a minus 1 by r of this term. So u r, this term. So 1 by r is minus cos over r cube. U theta is there, 1 by r, this is my r only. So if you take as r square, it is cos theta over r cube, and clearly says that this will be a 0. It's satisfied. That is also the solution of the problem. So B, C, D are the correct option of this problem. So you can see there are several shortcut tricks I can explain you, which will help you in the coming examinations in a very simple manner. I hope you can like this video, you can share this video with your friends, and subscribe my channel for more updates. Till then, best of luck students, happy learning.